Hi guys, welcome back to the next part of our series. Today we're going to take a look at the retopology process inside of Maya. And we finally have our character right here, but there's a couple of things that we need to adjust before we can start working on the actual character. First of all, we need to understand that there's something called a real world scale. It's a concept that I mention frequently, which is the size at which objects are created inside of a 3D world. Right now, if I'm here inside of Maya and I create a cube, this cube is going to be a really small cube. By default, this cube is 1 centimeter big, which means that this character is only like 6 or 7 centimeters high. And that's not usually what we would expect for a character like this. So one of the things that we're going to have to do is we're going to have to scale this character to real world scale. But there's a small little problem. And that's the fact that if we scale this guy and we create the retopology, if we then export the other meshes, this guy's right here, at a higher density so that we get more detail in our bakes, we're going to lose the detail because they're not going to match anymore. So you have two options. The first option is to go back to ZBrush here. And if we go to C plugin, there's one option called the Scale Master. And we can set the scales to a different a measurement. Right now, as I mentioned, this thing is set up to like 1 centimeter or 1 millimeter. So if we change this to like 10, right here, so C plugin, and we change the scales to centimeters, okay, and we export as centimeters, this should give us 10 times the size, right? So I'm going to again C plugin, set scene scale. You can also get some options right here where it tells you what's the scale should be. There's no closest option right here. Actually, let me go to the character. There we go. So if we take a look at the character, he should be probably like 3 foot, right? So if I go to C plugin and we go set scene scale, we should get some options like this guy right here. This 4 feet, 3 feet, and 1 feet. This is probably the closest size to the character. So I'm going to set that one right there. It's going to change a couple of things. So this is why I only do this at this stage of the process. And you can also do this manually by scaling inside of Maya. And then if we export again, we go File, Export. Let's export again as our Thyros full character and hit Save. We go back to Maya. Let's start a new scene. We're not going to save this one. And if we import back this new full character, what I'm expecting to see now is that the size of the character is going to be way, way bigger. And the reason why the character being bigger is good for us is because the tools that we're going to be using, such as the Quadro tool, work better when the polygons are really big. When they're really small, they start snapping and creating some weird effects. Okay, it's not working for some reason. That's really weird. I'm pretty sure we should have... Oh, wait, is it finishing? I thought it was already done. Give me 1 second. My bad. It was still exporting, and that's why we got that issue right there. So there we go. Now, as you can see, this is a closer size. It's a little bit big, but it's definitely better than what we had before. I'm going to grab all of the objects here on the outliner. I'm going to press Ctrl G, and I'm going to call this HP meshes because they're the high polygon meshes. And then one thing I usually like to work with the floor being on the bottom part of the character. So I'm gonna grab the mesh right here, or the group right here. I'm gonna press the D and the V to move this. And I'm gonna move this all the way down, and then I'm gonna press X to snap this to the floor. That should allow me to snap the group to the floor, and that way our character is above the floor. This is very important. We did change a couple of things here on the group, especially the distance. This is a distance that we're going to have to save later on to know how to displace the high poly meshes that we're going to be exporting eventually. As you can see, we have some meshes that are not working. I'm not gonna delete them because then I'm gonna forget about those. But I'm just gonna keep a mental note that those pieces were probably gonna be rebuilt or something here inside of Maya. Now that we have this, we can go and talk about the main tools that we're going to be using. And for that, I actually want to use this skull right here. So I'm going to go to the high poly meshes. I'm going to select all of them. I'm going to press H to hide them. Then we can look for one of this. We have all of these options right here. And we can look for the skull, which should be right here, skull jaw. Let's go for skull top. There we go. I'm going to press H again. That way we are... we can just work with one of the meshes without having to worry too much about this. So the retopology process, which is a process that not a lot of people like, but super important on the production pipeline, needs or invites us to create a new a new skin for this mesh that will have way better polygon distribution, which would give us a way better animation deformation, and which would, of course, reduce the amount of polygons that we have. And inside of Maya, it's super simple to do retopology. You just need to click the object that you want to retopologize, go up here and click this option, this little magnet thing that makes it live. And then once this is live, we can go to this option right here, which is the Quadro tool. You can also find your Quadro tool if you're in your modeling section on the mesh tools, and it's called the Quadro tool right here, Quadro. So the way the Quadro tool works, and actually before I move on, let me just turn on our little shortcut thingy. There we go. So the way the Quadro tool works is actually very simple. You only click on the object that is a live surface, and you will be creating points. And then if you have 4 points and you go shift and you create, or you click inside of those 4 points, you're going to create a new polygon, which is this that we're seeing right here. And then you can create 2 more points. This already count as points even if they're not green. You just press shift and you're going to draw a new poly count. And that way, you can just keep adding and modifying, creating the new topology for your object. This is the way we're going to be working, and this is the way it works for our characters. However, there's a couple of, again, golden rules that I would like to share with you in regards to retopology. Retopology is one of those things that a lot of people, they don't like to think about it because they feel like it's a waste of time sometimes. They feel like there are like automatic tools, and we will talk about the automatic tools, but I want to give you a glimpse of why automatic tools might not be the best. Take this skull as an example. If we go here into ZBrush, some of you might be like, well, we have Z-Remesher. We've used it before to model something, so why not just use it for the retopology? Well, one of the problems of Z-Remesher is that, yes, it will rebuild our surface. It will create a new remesh surface, but it won't be as optimized as what we can get manually. And it will also sometimes create things such as spirals, or it will just like soften things a little bit too much. You can see how the silhouette of the character got like really, really like reduced. Another thing that I don't like about this sort of like automatic tools is that they will sometimes give you way more topology in areas that you don't need. So for instance, we don't need all of these points right here. This section right here could easily be handled with like 12 or 20 polygons, and look how many we have here, okay? So manual retopology, as of today, as at the time of this recording, is still probably the best way to go when performance is important. And as a sort of like general rule of thumb, if you're going to be a prop artist or a character artist, you always want to be as performance efficient as possible. So one of the first rules, or one of the first guidelines that I would like you guys to follow is, whenever we're doing your topology, you should always want to keep a center line. This guy right here is aligned to the y-axis, or to the x-axis. If we go to the top view, you're gonna see, there we go. You're gonna see that we're down the middle, exactly down the middle. So that's great because we can make sure that we have a middle line, and then we just mirror to the other side, and we save ourselves quite a bit of work. So we always want to keep a middle line. We should always try to keep a middle line that goes all throughout the character. This is for 2 reasons. First of all, UVs are going to be way easier if we do it that way. And second of all, it's less work, right? Because we only have to do one side and then we duplicate to the other side. The second rule of thumb when doing retopology is you want to keep things as simple as possible for as long as possible, and then you start adding more complexity. What do I mean by this? Take a look at this section right here. It's very complex forms, very complex changes in silhouette. If I try to just like start adding a lot of little squares and stuff, I'm going to get a really dense mesh, and that's not really the ideal thing. I need to think about how this thing is flowing. Topology at the end of the day is the flow of the polygons. And I know, for instance, that this thing wants to flow down here. So I'm going to add one triangle that flows down here like this. I also know that this thing wants to flow this way. Well, we can add one line right there with control to add one section, and that tells me that this thing is going to flow kind of like this. And as you can see, we've now pretty much created a loop around the nose, which is going to be important. Then on this side, I can see that this thing right here wants to flow towards the direction of the zygomatic arc, like this, right? So we start adding, it's kind of like sketching, we start sketching the topology in this way. Over here, I can add one line, and you can see how this thing flows to this other side. On this side right here, I can see that this element right here wants to flow in this direction. So this will be like the general sketch or the general direction of our skull. And there we go. We've created another loop over here. We can create a closed loop over here, which is what we're going to do shortly. But this is how we plan out or how we think about our topology. Same thing for this like horn right here. Like I know it's very evident to me that this horn right here is a sort of like circular mesh. So eventually I would expect to have some sort of like circular base for this whole thing, like this, right? And then this thing keeps going up. So that's the second rule. Like you want to try to make sure that the topology flows in the way that it makes the most sense. On the eye here, for instance, we can create something called a loop. This squares or polygons right here are very stressed. They're really like stretched out and they're not really conforming to the surface as much. But if we add one more line, you can see that we get more geometry, more resolution, and that allows us to follow those lines a little bit better. Then from here, for instance, we can create a small little circular loop. Circular loops are super important because especially for deformation later on when we see the face of the character, they will allow us to create a closed loop that moves and contracts and deforms in a very clean and nice way. You can see how this creates the whole eye socket very easily. We can do a second one, like a second circle right here if we need to. So I'm just going to keep going. It's kind of like extruding. We're extruding this edges in and creating a circle. And then on this final part, remember how I mentioned on the ZBrush version that we didn't need as many polygons. Since this is a part that's like really flat and not as important, we can just start closing things. Like we can say, okay, I'm going to close like there, there, and there. Look at that, 6 faces, and see how much area we cover here. You can press Shift. Shift is a great tool to smooth things out and to help the geometry relax a little bit more. And that way we can create this section right here. So take a look and compare this topology that we created right here to this topology that we have right here. Now, does this mean that we can't use this one? No, of course we could use it, but it's very heavy. Imagine if we have 100 characters on the screen on our game and all of them have this sort of like level of detail. Some like game engines or game consoles will not be able to handle it. So that's why, again, like doing this sort of optimization is really, really, really important. Here we can keep going like this. Add one more line right there. And this is the second, or like I think it will be the third rule of thumb. You never want to work with small quads when you don't need to, okay? Because small quads tend to be very time consuming. So instead of drawing each individual section, you can start with the big sections like what we're doing right here. And then where we see we need more resolution or more geometry, we will add that geometry. So for instance, here, I can see that we could benefit from having a little bit of a break, so that we can start moving these pieces down into this like under section of the element. This line right here kind of want to go this side, and then we can finish like this, okay? So another like little square right there, that's fine. And then we just keep going. Trying to keep things straight, it's another one of the things that it's helpful for the overall like topology of our character. So we can go all the way over here. Here, and we're going to start seeing some other tricks in just a second. So there we go. As you can see, we're building our element. Now, for the nose, for instance, on this section, which can be a little bit tricky, we're also going to loop, very similar to what we did on the eyes. We're going to create a small little loop that's a closed loop. Hopefully you can visualize how when we mirror this to the other side, it's going to be a loop that follows along. So we do this right here. Here you can see that these two lines are really close together. You never want to have elements being really close. That's why the relax function is really important. And we still follow one of the first rules, which was the middle section, right? Like we want to have a center line because that's the line that we're going to be using to mirror the object to the other side. So we do there. For that, let's do another little like extrusion there. If we need one more line, that's fine. And then here, that's a square. This is camera based, so that's why I'm moving my camera around to find it. And there we go. We have a little triangle. We're going to talk about triangles a little bit more extensively in other parts of the retopology process. But triangles are not bad. We just need to know where and how to use them to get the best result. So that's it. As you can see right here, this is pretty much the basics of the retopology process. Now I'm going to show you one very cool little trick that we're going to be using, because as you can see, this is quite low poly. It looks like a PlayStation 1 or GameCube sort of resolution. And nowadays, we're actually allowed to have way more resolution in our engines than what we have right here. So what I'm going to do is I'm going to go to the right view. I'm going to select all of this center vertex, all of these guys right here. Very careful not to select ones that I don't need, all of these guys. I'm going to remove this thing, press R, and scale this and snap them to the center line. And then what we can do is we can press Shift, right click, mirror, and we're going to mirror on the Z negative axis with the world. We're going to combine with the original. We're going to use a merge threshold of 0.001 so that only the vertices that are close to each other merge. And we're going to hit apply. And if we did this properly, we're going to get this. So again, as I mentioned, this looks okay, but it's a little bit low poly, right? It's not the highest poly count that we can have. Here's the trick. Instead of having to work with a really high resolution, what we can do, let's bring this back into live surface, is we can work with low resolution like this, which as you can see, it's only 400 triangles so far. Only 400 triangles so far. And then we can say mesh and smooth. This is going to give us 4 times the amount of triangles. I'm also getting some n-gons. This is an unfortunate thing about Maya. For some reason, the mirror function sometimes creates some n-gons. We just delete those vertices. So again, mesh, and we smooth. And now we jump from 400 to almost 1800, right? Which is quite a bit. Still not as much as what we have right here. Remember, this is almost 24 or 22,000 polygons, but this is quite a bit of a resolution. And here's the magic trick. If this skull is set to a live surface, we can grab this new softened or smoothed version, and we can say mesh conform with a 0.001 along normals and hit apply. And what this will do, as you're about to see, look at this. It conforms to the surface way closer to what we have, and we get something that's a lot closer to what we would normally expect on a AAA game nowadays. So yeah, this is it. Now you can still reduce the amount of polygons, because at any point it can be like, hey, you know what? Maybe this loop right here and this loop right here, we don't need it as much because it's not as visible. We just press Control and Delete on our keyboard. As you can see, we don't lose any of the silhouette, and we just reduce the amount of polygons. Same for the lines right here. I can see we have quite a bit of center lines, like all of these guys. Control, Delete. We don't lose as much detail, and we're creating something they sometimes refer to this as LODs, which are the level of details. But this is the trick that we're going to be following. We're going to be doing a very low poly version of our element, as low as we can get it, which in this case is something like this. And then once we're finished with the low poly version, we're gonna smooth it to get way more resolution where needed. Okay, so in the next couple of videos, guys, I'm gonna finish this skull to again keep hammering some of the concepts that we're gonna be looking at in regards to retopology, and then we're gonna jump onto ZBrush and onto Blender to show you some of the techniques that we can have there for retopology before we jump to the next chapters where we're actually gonna be focusing on each specific part of the character. So hang on tight, and I'll see you back on the next video. Bye bye.